right, last set of notes for this unit. All right, so what we're working on is solving systems that involve a 3x3 system, as we call it. So 3x3 system, 3 equations, 3 variables, hence the name 3x3. So looking at our foldable, we can use either the elimination method or the substitution method for solving these. Again, it depends on what the equations look like. You have to look at the equations and be able to figure out from the way that they look which method is going to be your best bet. So let's take a look at our setup here. So here's an example of what it looks like. As you can see, we have 3 variables, 1, 2, 3, x, y, z. We have 3 equations. So 3x3 system. Now, I am fully aware that this does not have a letter z, but it still is part of our 3x3 systems. So your goal, again, is to eliminate letters so that you can solve for the other ones. So looking at this first one, I like to label them as A, B, C. So if I talk about equation A, you know which one I'm talking about. Or if I say C, you know which one I'm talking about. It's a little easier to deal with things there. But looking at this, because C already has the letter Z missing, I want to create another equation by combining A and B so that they also have Z missing. I got to get rid of a Z a second time. So looking at this, to get rid of Z, one's already positive, one's already negative. So going along with our other elimination notes, that's what we needed. I need to make this a 6. So to do that, I'm going to do A plus 2 times equation B. That's what I'm going to do here. So I'm going to recopy A. And I don't do anything to it. Equation B, I'm going to multiply everything times 2. So that's my 2 times B. So A plus my 2 times B. So now I'm going to add everything together. My z's eliminate. So I get negative 2x plus 15y equals negative 9. I'm going to call that equation D. D is for dog. So now my equation C and my new equation D both only have 2 variables. They both have just x and y. So now I'm going to eliminate either x or y. So looking at my 2 equations, I feel like probably x is going to be the easiest one because they both already are the same number. So I'm going to do C plus negative D. I'm going to multiply my new equation D times a negative 1. So I'm going to recopy C. Again, multiply D times negative 1. So that's just going to change all of my signs. Adding them. So x is gone, negative 18y equals 18. Divide by negative 18, and we have our first answer. Y is a negative 1. So now we're going to go back to either C or D, and we're going to plug in our y value. I'm going to use equation C. So that gives me negative 2x plus 3 is 9. Subtract my 3. Divide by negative 2. I got my x is a negative 3. So now I'm going to go back to A or B and plug in my two answers that I got for x and for y. I'll use A. So 2 times negative 3 plus 5 times negative 1 plus 6z equals 1. Okay. So that gives me negative 11 plus 6z. Add my 11, divide by 6. Z is a 2. So much like our other ones, you can leave it like this where you have x is a negative 3, y equals negative 1, z equals 2. Or you can write them like this in parentheses. That also works. X, Y, Z always go in order. Alpha order, if you remember, X, Y, Z. All right. So it's same elimination process. It just does take a little bit longer because there's three of them. You're trying to find three variables and you got those three equations that you're dealing with. So looking at number two is a little different because each equation has all three. So I have to look at my options and try to figure out which letters are going to be the easiest to eliminate. So again, I'm going to label ABC. So I feel like the y's are going to be the easiest because all three equations already have y's that are the same coefficient. It's just I also have one that is already negative. So I'm going to do that. So I'm going to start with a plus b so that I can eliminate my y. Now I didn't multiply either one times anything. I left them the way they were because they were already set up perfect for my y's to eliminate. So equation D now is negative x plus 6z. So now I'm going to do that process again, but with B and C. I didn't have to do this on the first one because C already had Z gone. I don't have that this time around, so I need to do this first step twice and adding and combining some equations twice so that I can eliminate a letter. Boop. So negative 7x plus 8z equals negative 3. And I'm going to call that E. So I got D and I got E. And both D and E now only have x's and z's. So now I need to eliminate another letter. I have a negative 1 and a 6. I have a negative 7 and an 8. I feel like my x's is going to be the easiest to eliminate. So I do negative 7 times D plus equation E. So by doing that, it gives me 7x minus 42z. I almost wrote x again. Negative 133. And then E is going to stay the way it is. I'm going to add them together. So my x's are gone. Get this out of my way. Negative 34z equals negative 136. I'm going to grab my calculator here because my brain is struggling a little bit right now. Yep. Okay, so divide by negative 34. I have my first answer. Z is a 4. So I'm going to go back. I'm going to use my equation D, and I'm going to plug in my 4 for Z. So that's a 24. Subtract my 24 over, and I get negative 5. Divide by negative 1. And x. You didn't see any of that. I'm so sorry. X is a 5. And so now we go back to one of the equations at the beginning and plug in our x and our z. Y plus 14 is 15, so y is a 1. So again, you can leave your answers like that. You can also write them in alpha order in a set of parentheses. That works as well. So elimination method, you're just using elimination method over and over and over again. Let's take a look at our substitution method. This one is going to be different because as you can look, the equations are all different here. So like this first equation only has 2 variables. The second equation only has 1 variable. Again, I'm going to call them ABC. And then equation C has all 3 variables. So this one is a different setup than the last one. So just looking at it, I'm just going to start with equation B. All I have to do is divide by negative 2, and I have my first answer. X is a negative 5. So then looking again at my options, I'm going to use equation A next and plug in my negative 5 for X. Negative 20 minus 5y equals negative 5. Add my 20, I get 15. Y is a negative 3. And so now I'm just going to use equation C and plug in my x and my y. So that's negative 15 minus 3 plus 60 equals negative 12. So that's negative 18. Add my 18, I get 6. Divide by 6, z is a 1. So x is negative 5, y is negative 3, and z is a 1 on that one. That one was pretty easy compared to the other two we've done. All right, taking a look at number 4 here. So for number 4, again, we'll take a look at what we have. We have all three. This one only has 2, and this one's set up differently because this one actually has that y equals there. So what I'm going to do is I am going to take that y equals, and I'm going to plug it in. Sorry, I forgot my ABC. So I'm going to write it like, oh, sorry, B. Sorry, I got distracted. Class just walked by. So I'm going to plug that in. And then I'm going to combine everything that I possibly can. Minus 4x plus 16 plus 2z equals 16. So that gives me x plus 2z equals 0. I'm going to call my new equation equation D. So x plus 2z equals 0. That's my equation D. So now what we can do, we can do the same thing with A. So 3x plus 4 times x minus 4 plus 5z equals 2. So distribute. X plus 5z equals 18. There we go. So now we have D and E, which both have just x and y, or x and z. I got rid of y. So now I'm going to, probably going to go for the x's. I'm going to do negative 7 times d. I'm going to use my my elimination method now. You don't have to only use one method. You can combine methods, which is what I'm doing. So negative 7x minus 14z equals 0. I didn't change my equation E at all. And I get z is a negative 2. So again, I'm going to go back, plug my answer in. I'm going to use D. X plus 2 times negative 2. I get x equals a 4. And then I'm actually going to use equation C. Y is x minus 4, so y is 0. You just got to look around at the equations, see how they're set up, and then pick your method from there.